Welcome to EDU World Space.
Okay, so once again, welcome to a new problem. This time we have an air truck, which happens to be frictionless. We have a frictionless air truck, and we have a glider on the truck, and it's moving towards the right, which is the positive direction. We have another glider moving towards the left, which is negative direction. The mass of the first glider happens to be um, MA, which is 0.150 kilograms. The mass of the second glider happens to be 0.300 kilograms. The initial velocity of the first glider is the same as 0.80 meters per second. And then the final velocity, or the initial velocity of the second glider, because it's moving towards the left, we're going to make it negative 2.20 meters per second. So we want to find the final velocity. So after, this is the before scenario, and then this is the after scenario. So in the after case, what happens is that they collide head on, and then potentially bounce off of each other. So that's what's happening with these two gliders. This is an elastic collision. There are no losses of energy. So then when they bounce off, we'll have a final velocity for the first glider, VA final. We want to find that. So that's what we want. And this is what we're given. And then we also want to find the final velocity of the second glider. So, these are the questions we're asking ourselves in these two problems. The first thing we want to do is use the law of conservation of momentum that says the initial momentum of the system equals to the final momentum of the system. And that just means that MA, initial velocity of A, plus MB, initial velocity of B, equals to MA, final velocity of A, plus MB, final velocity of B. We can always plug in the relevant numbers that were given. And so, we're going to do that in the next page. So mass of A, checking back, mass of A is 0.15. So 0.15 kilograms times the initial velocity of A, which is 0.8 meters per second, plus mass of B, which is 0.3 kilograms. And then we also have the final velocity of B, which is negative 2.2 meters per second. And we're going to make that equal to the mass of A, which is 0.15 kilograms, times the final velocity of A, which we don't know, but we're going to find out in this problem, plus the mass of B, which is 0.3 kilograms, 0.30 kilograms, and then the final velocity of B, which we also have to find out. So if we simplify this problem, we get to see that we end up with, on one side we have negative 3.6. This is momentum. It's a momentum problem. So we have negative 3.6 equals to actually we need to plug in the numbers. Let's see what happens. We have to plug in these numbers. So we end up with, using a calculator, we end up with so 0.15 times 0.8, and then minus 0.3 times 2.2. So this is negative 0.54 kilogram meters per second is equivalent to 0.15 kilograms. Okay, 0.15 kilograms. And then you notice something special about all of this. This is 0.3, so we can pull out. If we pull out 0.15, we're left with final velocity of A plus twice final velocity of B. Remember distributive property. If you do that, you're going to end up with what we exactly have right there. And then we divide both sides by 1.5 kilograms. Not 1.5, but 0.15 kilograms. And so we have an equation that says negative 0.54 divided by 0.15, 3.6. So negative 3.6 meters per second equals to final velocity of A plus twice the final velocity of B. So that's one equation we've come up with. On the next page, we see that the final velocity of B. So let's see, we have B and A. Yes. So the final velocity of B, I have to clean this up a little bit. So this one says the final velocity of B minus the final velocity of A equals to the initial velocity of A minus initial velocity of B. So these are what we call relative velocities before and after collision. Relative velocities before and after collision. That's going to help us come up with a new equation. So we get to see, we plug in the numbers, we see that the final velocity of B minus the final velocity of A. We know what the initial velocity of A is 0.8 meters per second minus the initial velocity of B, negative 2.20 meters per second. And this gives us the final velocity of B being equivalent to the final velocity of A plus 3 meters per second. So we have that equation, and we're going to combine it with this other equation simultaneously. So, in the next page, we get to see, we can write both the equations out. Negative 3.6 meters per second is final velocity of A plus twice final velocity of B, as you can see, negative 3.6 meters per second. And then in the second case, we have VB final equals to VA final plus 3 meters per second. So VB final plus VA final, VB final equals to VA final plus 3 meters per second. So this is an equal sign, 3 meters per second. So we want to plug in the final velocity of B right there. So we end up with negative 3.6 meters per second equals to VA final plus twice uh, final velocity of A plus 3 meters per second. Um, and then we could do some substitutions here. We solve for the final velocity of A, so we have negative final velocity of A plus 2 final velocity of A uh, plus 6 meters per second equals to negative 3.6 meters per second. So 3 final velocity of A equals to, we move that to the other side, negative 9.6 meters per second. And in the next page, we can always get the final velocity of A, which happens to be negative 3.2 meters per second. So on this one, we're going to say the final velocity of A equals to negative 3.2 meters per second, means that it's moving towards the right, towards the left, sorry. So the magnitude is 3.2 meters per second, moving to the left, and then now we can always go back and use this equation, right here to get the final velocity of B. So the final velocity of B equals to the final velocity of A plus 3 meters per second, which is the final velocity of A, negative 3.2 meters per second, plus 3 meters per second, and that gives us negative 0.2 meters per second. So then we finalize this by saying the magnitude and direction of the final velocity of A is negative 2 meters per second. In terms of numbers, you could say the magnitude of final velocity of B is 0.2 meters per second, and it's moving to the left. Hope you enjoyed the video. Feel free to send any questions, and if you have any comments, you can also reach out. And thanks for watching the video. I hope you enjoyed it. Okay, bye.